Understanding how data is related to each other becomes really, really important as we start our journey into the data analysis field. What I'm showing on the slide right now is just a sample set of tables and some of their relationships. Tables are one of the foundational structures in data modeling. As the definition states, it's a collection of related data, right? So we were talking about if it's customer, we want to have a customer table. So it's a structured format in which databases create these tables. So I've given an example of a country table. Let's go try to look at each section of the table. So the stuff that's highlighted in orange are basically the attributes or columns. So we have country ID, we have country, and then we have last updated column. Country ID listing individual unique IDs, and then the country is listing the textual information, and then there's a time value for last updated. So these are columns or attributes. If you look at the bottom section of the slide, created that in green, those are actual values or data elements. So data elements are, if you look at the last row, country ID 9, so 9 Austria. Each of these individually are data elements. If someone says, how many columns do you see in this slide? So I would say 3, country ID, country, and last update. Data is added as rows or tuples. So if you look at horizontally, country ID 2, Algeria, and the last update value, that row becomes one record in the database. Another important concept is of primary key. Each of these rows that you see are identified by a unique identifier. So country ID 1 through 9 is unique. 1, 2, 3 up to 9. So you don't see that being repeated. Understanding the way tables are structured is very important in defining the relationships that we're going to learn in the following slides. We will be talking about data types, or in other words, you can say is the type of format that a column has in the database. So whenever we try to insert a data, we need to know if it's a date, if it's a string, or if it's a number. So for a date column, date of birth. In this example, the format is first YYYY is the year portion, dash MM is the month, and dash DD is the day. So 2000-10-10 would be the format of a data element. And the second date format is a date where we have hours, minutes, and seconds as well. So for certain scenarios, we can have the date field defined in a more granular way. So date would be the first data type. Second data type is strings. So strings are more or less, in a case of customer table, we can have customer first name, last name, anything textual. And then we have two variations, a varchar variable character and the character. We don't need to go too much into detail, but they both hold string values. The third category of data types come under number. So anytime we want to store numbers, for instance, your car's mile, like we were talking about an automobile table. So if you have mileage for the car, that mileage column can be stored as a number. So for number, you can have a data type of an integer or a small int, depending on how big the number is. Or if we have decimal places we want to represent, like for instance, the customer paid amount, like if you paid for a Starbucks coffee and the amount was some dollars and then some cents. So we can represent that by a data type of decimal. If you know the data types and the category of date, strings, and numbers, you can do majority of the data analysis knowing these data types. We will be talking about the notations that we will be using in our relationships. So before we get into the different types of relationships, I just want to make sure we understand the language in which we're going to be depicting our relationship. So we're going to be using information engineering notation. So the process of designing the tables and its relationships is called entity relationship modeling. So if you look at the cardinality, that's just the maximum number of connections you can have between the two tables. So one would be just one vertical line, many would be a crow feet. Modality is just the least number of connections you can have in a relationship is 0 or 1. When you see a relationship in action, you will have both the maximum and the minimum number of relationships those two entities or tables can have. So that's why if you look at the right hand side, showing a cardinality and modality together, so the first relationship is showing one or many, and that's why you see the symbol for one as a vertical line and for many as a crow feet. The one at the bottom is zero or many, and you have a circle and a crowfoot. So just getting an understanding of the symbols will really help you in the following slides. All right, now we will talk about different types of relationships that two tables or entities can have. First one is one-to-one. As the name suggests, it says one entity can only have one relationship with entity 2, and entity 2 can only have one relationship with entity 1. So if you look at this example, we have a relationship between a manager table and an office. If you just look at the manager table, we have manager ID, first name, last name. So there are four different managers in our table. And if you look on the right hand side, we have an office table. So we have four different offices: Chicago, New York, Seattle, and Columbus. So that's the data we are dealing with. If you look at the manager table, we have manager ID as the primary key. And in the previous lecture, we defined what a primary key is. It's a unique identifier. So manager ID 1 only relates to Eddie. Manager ID 4 only relates to Paul. If you look at the office table, we have primary IDs as office ID 1 through 4. And then also we have another column, manager ID, in the office table. So what it shows is that office 1 is managed by manager 1 and location is Chicago. So manager ID being in the office table, this particular column is a foreign key because it is present in the manager table. So now there's a parent relationship. And if you look at the line that connects these two tables, it's a straight line with two dashes on the side. So what that depicts is that the manager can only manage one office. If you look at from the office to the manager side, it says office can be only managed by one manager. So it's a one-to-one relationship. It's a mandatory relationship as the modality is also showing 1 with the vertical bar, and the maximum relationship is also 1. And another example can be US citizens and a social security table. So US citizens table, which has a first name, last name, and then another table as a social security. A citizen can only have one social security, and a social security can only be related to one citizen. So hopefully that kind of clears that up as far as the relationship setting. So it's a one-to-one. So in this case, a manager manages one office, and an office can only be managed by one manager. All right, so the second type of relationship is one-to-many relationship. This is one of the most common relationships that you'll find between tables. If you look at the example, it's between customer and order table. So if you just logically think in a scenario where a customer can have multiple orders, like if you go to Amazon, you can put 3 orders. So that's a legitimate business case, right? So you can have multiple orders, but that individual order, if you put 3 orders, that order one or the first order only relates to you, none of the other Amazon customers, right? So the order is linked to one customer, but the customer can put multiple orders. And if you go with that mindset, if you look at the relationship in the middle between these two tables, we have a vertical line on the left, meaning that the order can have only one customer. On the right, we have a crowfoot depicting the many portion of the relationship with the vertical bar depicting at least one. So the customer can at least have one order or many. And again, we have a primary key and a foreign key. So the primary key on the customer table is the customer ID, and the primary key in the order table is order ID. Great. But the order table also has a customer ID in it for this relationship to work. And that customer ID in the order table is a foreign key. And that customer ID is what that relationship is built on. Majority of the tables would fall into this category. Again, so if you look at this example, customers can put multiple orders and an order can only be placed by one customer. Third type of relationship is many-to-many relationship. Let's look at the example that we have. The first table we have is student. So it just gives you a list of students that we have. So student ID, first name, last name. Great. So we have a student table. Then if you look at the far right, we have a class table. It just gives you the different classes that are being offered. So English, math, chemistry, etc. So as long as student and class tables by themselves look fine, student has student information, class has class information. As we relate the student and class data together, there's an apparent many-to-many relationship between them, since the student can take multiple classes and each class can have multiple students enrolled in it. We have a scenario where this relationship can capture other information like student grades, enrollment dates, and for this, it'll be better to make a junction table called enrollment that will capture this information. If you look at the way student is linked to enrollment, we have a one-to-many relationship where a student can be enrolled in one or more classes. And if you look at the relationship from right to left, from class to enrollment, a class can have one or more enrollments from the students. As you go forward in the data analysis field, you'll see more and more relationships would fall into this category. A fourth type of relationship is called recursive relationship. And if you look at the example of employees table, so you have employee ID, first name, last name. You also have a fourth column called manager ID. So the managers are also taken from the list of employees. So there is a relationship between manager ID and employee ID. So if you look at the bottom half of the table, we have a relationship going from manager ID to employee ID. So a manager can manage multiple employees. So if you look at the tail end of the relationship, it's a crow feed saying many and at least one. An employee can be managed by one manager, or in some cases may not have a manager at all. So that's the other side of the relationship, and that's why you see employee 1 not having any manager ID. If we look at Mike and Jay, employee 2 and 3, they are being managed by Eddie, who has an employee ID of 1. And nobody's managing Eddie. He's a top level employee, and that's why you see manager ID has no information. So this is an example of a recursive relationship where we have a relationship within a single table, and manager ID is a foreign key to the employee ID column. So hopefully this was helpful. This type of relationship is rare to have, but it's good to know when doing data analysis. So now we have kind of looked at the building blocks of data modeling, what a table is, what are columns, attributes, what is a primary key or a foreign key, what are data types, and how tables are related and types of relationships that can exist between tables. Understanding normalization becomes important as more and more data comes into your database. So what normalization is a process in which we try to break a bigger table into smaller tables. And what it does is that it helps you reduce redundant data or duplicate data. Normalization goes through a few steps, and each of these steps are called normal forms. We go through first normal form, then second, and then third. And overall normalization, if you look at some of the benefits, is that you save disk storage. It's easy on maintenance for the database because you're updating less data. I/O activity gets improved, and also it helps query and reporting. I will show you an example of an employee table, and we're going to take that table from first normal form to second and then third normal form, and you will see the transition as to how we go through this whole process. And hopefully with this example, the normalization process of a table will become easier. We have been given this employee table and are tasked to normalize it up to the third normal form. Let's take a step back and look at the data closely. We have an employee ID, which uniquely identifies an employee, a department code that is unique for a department. We have employee name, department, three columns that have phone numbers in them, employee start date, and employee vested indicator. So that's the data that we are dealing with, and we have to take this table through the normalization process of first normal form up to the third normal form. When you're dealing with the first normal form, you need to ask two questions. Are there any repeating groups, meaning are there two or more columns that are closely related to each other? If they are, we need to create a new table for them. Second, make sure that all the attributes are single valued attributes. Let's take a look at the employees tables. If you look at the employee name, we have first name, last name in one column. That's our first candidate, as we should not have any multi-valued attribute. So what we do in the first normal form, we split the employee name into the first name and last name to take care of the multi-valued attribute. If you look at the first phone number, all the phone numbers there are different, and it has to be the employee phone number. Phone number 2, it seems like that phone number is dependent on the department. If you see finance, the finance department has the same number, so it is the department phone number. Phone number 3 has all the phone numbers being the same. That can be looked at as a company phone number. Employee start date and employee vested indicator can move as is. We also improved the metadata or the column names for all the three phone number columns and add employee department and company labeling to them as it makes more sense. Now our employee table is in first normal form. Let's get that ball rolling to the second normal form. The most important question you want to ask is when you're transforming your table from the first normal form to the second, is that to make sure that all non-key columns are functionally dependent on the entire primary key. So what are the non-key columns? Employee last name, employee first name, department, employee phone number, department phone number, company phone number, employee start date, and employee vested indicator. These are all non-key columns. So what the rule says that they need to be functionally dependent on the entire primary key. So the primary key here is employee ID and department code, right? Those are the unique identifiers. But if you look at the employee first name, last name, that is dependent on the employee ID. An employee ID should be able to give us the employee first name, last name. If you look at the department, department is dependent on the department code. So you see, We have some columns in the table depending on one part of the key, and the other columns are dependent on the other part of the key. So what we need to do is we need to split the table where the columns are dependent on the whole key. So that's why you see the employee table being split and having the employee first name, last name, phone number, employee start date, and employee vested indicator. They're all dependent on the employee ID. For department, you see we have department phone number, and the company phone number that are dependent on the department code. Great. So we have those two tables transformed into the second normal form right now. We also need to capture the relationship between the employees and the department data. Right? Employee can work in different departments and the department can have multiple employees. As you recall from the earlier lecture, to resolve a many-to-many relationship, we had to create a junction table. So in this case, it'll be the employee assignment where we're going to have an employee ID and a department code as being the two columns in the relationship. So if you look at the relationship from employees to employee assignment, is a one-to-many, and if you look at from department to employee assignment, is also one-to-many. So how are you going to capture the relationship and have the employee and department being in the second normal form? Great. All right, let's get the ball rolling. For a table to be in third normal form, we should not have a situation where an attribute depends on another attribute that is not the primary key of that table. It's also called transitive dependency. Very important rule that the non-key columns in the table should not have dependence between them. Secondly, we should not have any derived data, such as like total columns that are derived from other columns in the table. So if you look at the employee table, we have employee vested indicator that is dependent on the employee start date. So for a certain start date, the indicator either turns yes or no. So that is definitely one candidate that we can address in our third normal form. So if you look at the employee table, in the third normal form, we only have first name, last name, phone number, and start date. All those columns are only dependent on the primary key, and there's no dependency between the non-key columns. If you look at the department, that is already in the third normal form. As you go through different projects and as you go through your data modeling assignments, you'll find that the third normal form is where majority of the transformation stops. There are some higher normal forms like boycott normal form, fourth and fifth normal form, which do occur and people do use them, but very rarely. I will try to add some slides for those normalizations at a later time. All I will say is that with practice, data modeling becomes easier and easier. You need to understand the business as to how the data is captured and what the data means. Practicing the normalization rules and being close to the data will help you in your data modeling projects.